Hello, geometry students. Today we're going to look at the equation of a circle. Now, we've studied a lot about circles, but now we're going to be looking at what if we want to have an equation. We put that on a graph, and what would the equation look like? We know that the equation of a line, but what's the equation of a circle? That's our question for today.
Here we have an example of some circles, but none of these are on a graph. Why would we need to graph a circle? One of the reasons is that the computer screen is a graph. And if we want to tell the computer to draw a circle, we're going to need to know the equation of a circle. That's just one application, but there are many more.
So let's put the circle on the graph and say, well, maybe I'm going to put it right there. So how would I tell the computer or anybody what points would be on the circle and what points would not be on the circle? Well, first of all, I have to know where the center is. So I'm going to put this center at 5, 4. Okay, now I have the circle drawn, and I might notice that the radius is 10. It starts at 5 and it goes out here to 15, and that's the radius of my circle. And every point on the circle is going to be 10 units away from the center. So I'll draw in a radius here. This is what we call an arbitrary point. It's an unknown point that we're going to solve for. So I'm going to say the coordinates of this point are x and y, representing the x coordinate and the y coordinate of that point. Any point on the circle could be represented with x and y. Those will be variables. In order to derive the formula for a circle, we might want to remember find the distance, take the square root of x2 minus x1 squared plus y2 minus y1 squared. The distance formula. Because really what we have is a distance. The distance here is 10. That's also known as the radius. Here is the distance formula. So if I just plug in my different values for the distance formula, I should have an equation of this circle. This point right here is my x1, y1. And this right here, I'm going to call x2, y2, even though that's a particular point, but I'm going to use variables. So when I plug this in, I'm going to plug in for the distance, that's the radius, r equals the square root of x2 minus x1. That's x minus 5 squared plus, and that would be y minus 4 squared. Oh yeah, the radius is 10, so I could just make this a 10, and I have the equation of this circle. Now, if I want to get rid of the square roots, it might simplify things a little bit. I would get 100 equals x minus 5 squared plus y minus 4 squared. Normally, we put the radius on the right-hand side, and that would be the equation of this circle. Now, if I want to do that work in general, I would just plug in r for the distance, and I would plug in, generally we use h and k for the center of the circle. So a circle with center hk and radius r is x minus h squared plus y minus k squared equals r squared. And that would be just from the distance formula. This is also related to the Pythagorean theorem. We might recognize seeing the Pythagorean theorem in this, a squared plus b squared equals c squared, because really we can solve this with a triangle as well. So some of you might see this if this is a triangle. Then I could represent these lengths a and b as x minus h and y minus k. We looked at that a long time ago, but that's how this formula relates to the Pythagorean theorem, and the distance formula relates to the Pythagorean theorem. Let's try just a couple of examples here. The first one is x squared plus y squared equals 25. If we want to graph this circle right here, then we need to know where the center and the radius is. So I need to put it in this form right here. So I'm going to try. Notice x minus h. There's no h here. There's just x squared. But we can use a 0 when something's missing like that. So x minus 0 squared is the same as x squared. And y minus 0 squared is the same as y squared. And what's the same as 25? Well, that would be 5 squared is 25. And now it's in standard form, and we can just pick out the center and the radius. The center is at 0, 0, and the radius is 5. So equals 5. So that's basically it. If I had a center 0, 0 and a radius 5, then I'm coming here, 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 and here for the edge of my circle. And I would just try to draw a circle here. I could use my compass. I'm going to try to make my best circle. Okay, that's best I can do. Now, in number 2, I have x minus 3 squared plus y plus 2 squared equals 13. So how would I find the center and radius of this circle? Well, first, let's put it in standard form. So this needs to be x minus h, which is in that form. This one needs to be y minus k, but that's a plus. But we're going to separate that plus into 2 negatives. So it would be y minus negative 2 squared. That would make a plus. Equals 13. Well, I have to take the square root of that, and it doesn't come in evenly. So I'm going to say that's the square root of 13 squared. So now I can find my center and radius. The center is the point 3, negative 2. I ignore the negatives here because those are in my formula. I just take this value for h and this value for k. Now the radius equals the square root of 13. I ignored the square because I'm just taking that part, the square root of 13 for my radius. So if I wanted to plot this point or this circle, I'd start with the center at 3, negative 2. 1, 2, 3, negative 2. That's my center. And my radius is the square root of 13. That's approximately equal to 3.6. Pretty close. So let's go out 3.6, 3.6, 3.6, and 3.6 in 4 directions. And I'm going to make my best circle through those points. One thing we can do is we might wonder if a point is on the circle. So I'm looking at this point. This is point 1, 1. And it looks to me like it's on the circle, but I may not have drawn that in perfectly. So if I want to check a point, so I'm going to check point 1, 1 to see if it's on the circle. So I would plug it into this equation. So the x is 1, so it's 1 minus 3 squared. The y is 1, so that's 1 plus 2 squared equals 13. And just solve that to see if it's on the circle. Yep, it's on the circle. So that's how I would check to see if a point is on the circle. Let's go ahead and look what a computer could do with this equation. So here I have actually entered in this equation, and the computer drew the circle. And there's my point 1, 1 that I have right there that I checked. And we might look to see there's some other points on this circle. And if I want to move the circle around, I just have to change these parameters. So let's take a look at this equation here, this circle, and I'm just going to move one of the parameters like h. So I have over here that I can move h, and h gives me the x coordinate. I could change that to wherever I want to, and the k would give me the y coordinate that moves around, and the radius, I could change the radius. I could set this on animate, and this is just going to move around on its own. Now it just looks like a game of Pong. This is actually like the original game of Pong. Let's go ahead and give it some borders here. Okay, well, that's the equation of a circle. I hope you found this video enlightening. To find the distance, take the square root of x2 minus x1.